Hey guys, this is Brian. I met a lot of you at the MACA conference back in May. Sad it's over. I'm anxiously awaiting next year. I'm excited to go back. But while I was there, got to talk to a lot of you and hear about a lot of your experiences in crime analysis and how things go in your department. And I got to match that along with the stuff I've been reading about online. And a common trend I kept hearing about or reading about was two things. One was budgetary concerns. It seemed that departments are always under scrutiny about how much money they're spending. And the other was around efficiently handling your data. And that's it's two parted really. It was getting it out of the RMS and then also ensuring the data integrity. And so the more I talked to people, the more I was thinking in terms of the programs I use at work, and my favorite being R. It's this program, it's just the letter R. And I kept thinking about how that might help some of these issues that we're finding in our departments and our jobs across all fronts, including budget and managing our data. And so I was talking to Glenn Mills one night, and he's a big proponent of open source software, as am I. And he was saying, well, maybe you should put together just a quick little tutorial on what R can do, and we can put that on the website and show people and see where it goes from there. And I thought that was a great idea. So that's what I'm going to try to do here. There's going to be a lot of stuff I go through where I'm not really going to touch on how it works or why it works, simply because this is meant to show what R can do as it relates to the field of crime analysis. But if there's feedback in terms of people saying, this looks great, we want to know more, I'd be more than happy to put together more tutorials that really dive down into R and say, okay, this is how this works, this is what you need to do this, these are the packages you need to install. But for now, I just kind of want to go through and say, okay, what can R do in terms of reading data, manipulating data, querying data, running analyses, plotting, and even all the way up to social media analysis for things like link analysis or even text mining, and some of the things that might be able to do in the field. So let's just jump right into it. I'm going to go ahead and open up RStudio. RStudio is a graphical interface for R. If you try to just run R, just load it up right here, you'll see it wants to bring it up in my terminal. And some of you might be familiar with the terminal, and you're looking at this saying, well, that doesn't look like my terminal. I run a different operating system than what you're used to. I run Ubuntu. It's a Linux distribution, again, just because I love open source. But a lot of you, if not all of you, are operating on Windows. But rest assured, everything's exactly the same. Nothing I do will be different from what you would do on your end. So a couple things might look different graphically, for example, the terminal, but RStudio and everything will look exactly the same. So I don't want to use this terminal. It's not as good. I can if I want, but I prefer to have the graphical user interface like we have here. So in RStudio, you're presented with 4 different panes. You're kind of like window panes. Your top left one here is your syntax editor. I can type anything I want in here, and it will not do anything. I can say, x is equal to ABC and hit enter, and nothing happens. But if I do it down here, then immediately over in our resource pane, this is where it tells you all the different variables, objects, data sets, functions, anything you define, it tells you what they are over here. So down in the console window, where if you type something, it happens instantly, it instantly created this variable x. So anytime I hit x or type the letter x and then hit enter, it'll return this value ABC. And so we have our resource window over here. Down here is where all of our plots will show up. So let's say I said we have a set of 100 random numbers normally distributed. I can say plot x, and it'll do that. We can drag this if we want to get more viewing area, or we can click zoom and it'll show up in a whole new window. I will give this disclaimer right off from the start. You have to be careful in R, because R will do exactly what you tell it to do regardless of what the outcome is going to be. So you need to be careful in terms of knowing what you want to produce and knowing what it should look like. So for example, if I say plot x, y, it'll give me a scatter plot of x and y, and that's great. That's what I was looking for, probably. But if, for example, I said, well, I wanted that to be a line graph, and so we told it to make a line graph, R doesn't know that that output is going to be useless. So it says, yeah, sure, I'd love to draw that graph for you. And here we have a third grader's rendition of a dragon, which, we'll hang on the fridge because we love them, but as an analyst, it doesn't do anything for us. So you just need to be careful in terms of what you're telling R to do. But for the most part, R is pretty intelligent, and if it's something completely wrong, it'll tell you. Otherwise, since you have a general idea of what you wanted it to look like, you can just check your results. So that's R. Let's jump right into seeing what it can do. First thing I do in every file or every project I'm working on is I'm going to set a working directory. I use this function here, and whenever I say function, a lot of you work in Excel, and so if you're not used to calling them functions, a function might be something like in Excel you type equal average A1, A2, A3, or A1 to A3 or whatever like that. And so the function here is average, and then the parameters are the cells that you tell it to look in, A1 to A3. So I'm going to use that terminology a lot in here, where a function is just anything that you want it to do, and then the parameters are the variables you're handing to it. So I'm going to use this function setWD, which is going to set my working directory, because currently, if you look here, my working directory is just home R. But for this project, I want it to go into data analysis, crime analysis data. And so I'm going to run that. Real quick, for some of you, you're looking at that tilde like what's going on there. For Windows users, that's just the same as writing something like this. So I don't have to write out the full file path. In Ubuntu, it knows that this just means home Brian, so I can kind of substitute that for there. But for you, you'd want to write, your C and then wherever you're going from there. All of these are actually already loaded for me, but in R you deal with packages. Packages are, think of them as add-ons for a software you might have. So in ArcGIS, the spatial analyst or spatial analysis add-on, I believe is what it's called. It's just an extension that builds on top of the features already in ArcGIS. So with R is built by statisticians for statisticians, so it's constantly being built upon. And whenever somebody develops something new, they'll generate a package if there's a lot of functions that they want to include. And so you install those, and then every time you want to use that, you have to tell R that you're going to bring that package in by saying library. So you say library, and for example ggplot2, which is a graphing package, you would say that, and then it would load that package for you. If you don't want to type that, another way you can do it is just going over here, and let's say, for example, I wanted to bring in the foreign package, which allows me to read SPSS and SAS files. I can just click that, and it'll load it for me. So I can just click this button. I can also click it to not have it in there. I won't go into why you don't want to load all of your libraries every time you start R. It's a little bit outside the scope of what I'm trying to teach. Just know that that's a taboo move. You want to only load what you want to use. So all of those are loaded for me, and we're going to clean that up a little bit, and then I'm going to load the data. Now this takes a little bit to run, so I'm going to run this and then when it's finished loading, we'll come back to it. Alright, so now we have our data loaded, brought it in. First thing I like to do is check to make sure that everything is what I would expect it to be. So over in the environment pane, we see 5.5 million observations and 20 variables. And so what we want to see is, does that make sense? And so another way of doing that is just typing in dim, that's the function, and the parameter is your data set. Because data sets are just a matrix, and so this is basically asking how many rows and how many columns. And this is what I would expect: 20 variables and 5.5 million rows. That's the data I'm used to working with. The next thing I might want to do is say, well, what variables do I have? You might be a new analyst in a department and you're not overly familiar, or maybe a new variable has been added to your data set and you don't know the name of it, or maybe you've got a variable that you keep typing wrong because you can't remember the format of it in terms of capital or lowercase. So you can type names, and what you get back is just a list of the variable names. It reads from left to right, top to bottom, and so if you were to count, right, ID is the first variable, and then if you were to count all the ones in the top, and then when you get to location description, this lock desk variable, you'll see that that's the 10th variable, and then if you counted more, you'd see that lat is the 19th and long is the 20th. So these numbers here represent what position this first element is in. So ID is the first variable, lock desk is the 10th, and then lat is the 19th. So those are our variables. And so something else we might want to do is say, well, what does our data look like? I'd like to just have a glimpse of the data and see if everything got read in properly. So we can use what's called the head function. And what the head function does is it'll take a matrix or a vector, and we'll gloss over what all that is, but it'll take either of those and return the first 6 observations. And so we see here we've got the ID, the case num, which is just the case number, the date, the time, which is an integer, ranges from 0 to 24, the block, which is just the street address, and then the street name, the uniform, the crime report number, the UCR, the crime description, location description, arrest, domestic, beat, district, ward, all these variables. So everything looks like it read in properly. The data I'm used to working with, this is right. And some of you might be looking at this like, ugh, God, that output, I can't work with that. There's got to be a better way. Please tell me that's not what I have to look at all the time. And no, you don't. You can do it differently if you prefer. This does take a little while to run, so I'm not even going to pause it so you can see how long it takes. And it doesn't always take this long, it's just the size of our data. But you do get a prettier output, what you're used to seeing in Excel. So let's just run that. The thing with R, what you saw with the head function, it's not always going to be that overwhelming in terms of output, but you are going to have a lot of on-screen text type output, and so you want to be able to be okay with that. But like I said, the view, it did take a lot longer to run than the head function, but you do get a nice clean presentation for your data, and so you can do that. One thing to note, don't freak out when you see this. View does only give you the first 1,000 observations. That's fine. You see down here that it just omitted them. It's not like you did anything wrong and your data's been deleted. It just only gives you the first 1,000. It will also chop off variables, but we only have 20, so it's not going to do that. So we have our data in. We have over 5 million records, and that is it's Chicago crime data ranging from 2001 to 2014. And I don't want to work with that much data. It's going to bog everything down. It's slow. Plus, really anything more than 5 years back, I can do everything I want to do with just a subset of data. So that's what we're going to do. First thing we're going to do is we're going to subset. I'm going to overwrite this dat variable. So everything that's done in R is done with variables. You store everything in an object. So your data is stored in an object, which means I'm not even working with my data file anymore. It opened it long enough to copy it into this object, and then it closed it out. Any changes I make to my data will not be permanent unless I save it. So I can do whatever I want. I can delete variables, I can change variables, I can do whatever without the fear of overwriting my actual data. But objects in R, everything gets stored there, and I overwrite them constantly. So here I defined dat, my variable, to be this data that we opened. Well, now I'm going to overwrite dat by referencing dat, and that's fine because R starts on the right hand side, does all of its calculations, and then shoves it into this new object. So it'll do everything it needs to do with our data and then put it back into this dat variable and overwrite what was there before. So real quick note about objects in R, so these variables. Everything in R, objects, values, variables, and by variables I mean in your data set, everything is case sensitive. So for example, let's say I define x to be ABC, and then I define capital X to be capital ABC. Those are different. I can type lowercase x, I can type uppercase x, and they are different. Similarly, if we look at the names in our data set, ID here is capitalized, both the I and the D. So if I try to look at the first 6 observations of ID in our data set, and I type it out lowercase, and I try this, it's going to come back and say null, because that doesn't exist. There is no such thing as the lowercase ID variable in our data set. So R is very sensitive in terms of case, so keep that in mind. But let's go in and rewrite our data set. What we're going to do is we're going to take the data set and we're going to subset it so that we're only looking at the years from 2009 to 2014. This shouldn't take too long to run, and it's done. And now if you look over here, we see that we've only got about 1.8 million observations now. We still have 20 variables. We didn't get rid of any of those, but we did get rid of anything prior to 2009. So that could be, you can think of that in terms of how you might create a table in SQL if you're used to doing that. So like if you were to type SQL code, you might do like create table dat as select star from, what would it be? Select star from dat where year is greater than or equal to 2009. You know, you might do something like that in SQL. And in full disclosure, I'm not that great with SQL, so I'll try to give examples where I can with the code I know in SQL or in Excel to try to bridge the gap between what I'm doing in R and what you might be used to doing. I'll do that where I can, but just know that my SQL knowledge is sparse. So we've created our subset of data. Next thing we're going to do is we're going to convert our date variable so that it's actually in a date format. And that's done. I'm going to create a new variable. So if we look, there is no month variable. And another quick aside, I'll do this throughout the entire tutorial as pieces of information come up or things that I feel I need to make a point on. You'll notice that I keep typing dat $, and then a variable, so like date or month, but it's always with that dat $. And here's why. If I do head dat $, date, it knows what to return to me. It returns the first 6 observations of my date variable. However, if I just said date, and I know that date is a variable in my data set, if I say that, it doesn't. It tells me it's not found, because what it's doing is this date name. It's looking for it over here in our values, and it doesn't find it there. So there's two places where variables can exist. One is in the R kind of global environment, so outside of your data sets, and they'll be listed down here under values. Or they can exist inside of data sets. In order to access those, you have to type the data set name and then a $, and then whatever your variable is, ID or month or or year or whatever else. So the $$ is how you get into your data variables, or whatever you name your data set. Let's say that you name it like my data or whatever, and you want to get to your date variable, or you just name it X. It's whatever you name your data set, and then a $, and then the variable. So the other thing is here, $date date already existed. So what it's going to do is it's just going to overwrite that. That's not a problem. Here, month does not exist. And so what it's going to do is it's just going to create it. And so if you look up here, we've got our 20th variable, which is long. There is no month variable. Let's create month. And it's as simple as that. We now have a month variable. Don't worry about what a factor is right now. I don't want to go into that. But it's just another type of variable. It's in Excel you can have a date type column or a number or a percentage. You format your cells. Factor is a format for your variable, and I'm not going to get into what it is, but that's best for months for us in this situation. This ordered is part of that. I'm not going to jump into what that is either. But I'm going to do the same thing for days of the week. And now that's created, and that was all based off of our date variable. I just said, tell me what weekday that is, and it gave it to me. And now I can look at day of the week, and it's all Monday. And here we see that Saturday is greater than Friday, greater than Thursday. So now the days of the week make sense the way that we think about them in terms of being an ordered. Here's something else. One of the things that was brought up, I think it was the very first presentation we had at the conference, talking about data integrity. And part of that is people who will type in street names or their narratives with all these different casings, like they're all uppercase, all lowercase. They're abbreviating street, they're spelling out street, they misspell street. They do all these different things that create a large number of similar values for, say, street or crime or whatever else, but they come back as different values because they're slightly different. So in R, you can use a function that allows you to look for patterns in the text, and then it's just going to replace what those patterns are. So for me, I'm a bit OCD with my data. I don't like when things are just all caps. I prefer the first letter of a word to be capitalized and then everything else to be lowercase. And so I can do that with just this one command, and it'll go through and it'll fix all of that for me. And now the first letter of every word is capitalized, everything else is lowercase, and I think that looks better. Even if it was the case where they were all uppercase, or maybe some were all uppercase and some were all lowercase, or maybe we had our 13-year-old child enter the data and so it's alternating case because that used to be really cool. We can look for those patterns and fix it so that they're all similar. And then we can also do things like, maybe someone types street or even saint, so they're going to type saint like that, other people type it like that. We can look for something, we can say look for an S, and this is just like the wildcards in Access, so we can do that and we can replace all of that, and that's possible here in R as well. So for example, let's say Racine. It's possible that somebody spells it with an S, so they spell it like Racine and others spell it like Racine. We can do we can do something like this, and it'll parse through and it'll find my pattern was extremely vague. You know, you'd want to do something much more detailed. But somewhere in here, we would find our Racine Street. And so R does have text analytics like that to allow you to look for patterns and kind of correct your data and enhance the data integrity for what you have going on. Something else it's good at is aggregating or reshaping data. So if we look, one of the things we have is crime. We also have year, and maybe one of the things we want to know is how much crime takes place each year by crime. So I don't only want to count the number of crimes that took place in a year, I want to know the count of each type of crime that took place each year. And so I can do that. And so if I use my aggregate function, what is going on? Oh. So here's a good example of when R will yell at you. So I told it to look in a data frame called dat.s. This is residual syntax from something else. Dat.s doesn't exist. And so it said, no, I'm not going to do that. You messed up. But the error codes are helpful. Object dat.s not found. Okay, well, where do I type dat.s? Okay, I have it typed here and here and here. So I need to go back and I need to replace those. And then I'm creating this variable x1, and then I tried to use that variable x1 to do something else, and it said, well, we never created x1, we stopped that, and so x1 isn't found either. So let's go back and fix that. And we can fix that by just getting rid of the s's. So if we run, and it's going to aggregate all 1.8 million records by both year and crime type. The aggregate function, whoever wrote that algorithm, it is a bit inefficient, but it's very powerful in terms of summarizing your data, or kind of rolling it up so that you don't just have one record per row. You're going to have all of this data that you want to look at. So let's do our prettier output of view x1. So in 2009, arson, 616. 2010, there were 519 arsons, and we can keep looking at it this way. Now, that's great, okay, having each year down, but what I might like is if I just had a row for each type of crime with the year, so this count being my column. So this would be column B, I guess. If we were to get rid of this year, we would move crime, and I'm trying to paint this picture in Excel for you. So crime might be column A, and then we'd have 2009, this 616 in column B, 519 in column C, 507 in column D. It turns out we can do that. It's very fast. So let's look at x.2. And now that's exactly what we have. We have arson, we have all the crimes that took place for assault and for everything else going on. Now, one of the things is, if you look in my code, I didn't point this out, but I told it to exclude concealed carry license violation, and that's because that did not become a crime in Chicago until 2014. Pretty confident you weren't allowed to have guns in Chicago until recently, and so now it must be the case that you can have a concealed carry, and they're actually getting some violations on that. But because it only showed up in 2014, it puts it into columns where it shouldn't be. So again, you have to be careful with R, because it would have put that under the total 2009 column. And so you have to be careful, because sometimes it's not going to do what you think it's going to do, or it might not operate specifically the way you want it to. So as long as you know what to look for, you can catch it, but it is possible for R to slip some stuff right under your nose. But this is a nice little example of reshaping your data, completely changing it. Remember before, we had 1.8 million rows, all just these different crimes that happened on different dates, and now we've just completely summarized our data. We can look at this across and see just exactly how many arsons took place in 2010. We could have done the same thing using a crosstab. So if we would have said something like this, if we would have looked at crime by year, we can pull up the exact same thing. So you see arson 616, 519, 507, matching the same numbers we have up here. Only difference being this is a table, this X2 is a data set. So that's a few things you can do at the kind of 30,000 foot view with your data. Reading it in, manipulating it, or by manipulating I mean subsetting, overwriting variables, adding variables, reclassing variables, so reformatting them to be a different type of variable, going in and changing the values so that they're all uniform, and then reshaping your data in terms of aggregating it or rolling it all up so that you can work with that as opposed to the individual level of crime. So what about descriptive statistics? And I mean things like mean, median, the range, min, max, running frequencies, things like that. How does R handle those? Well, quite simply. First thing you might want to do is just run a summary of your data. And again, with a lot of records, this can take a second to run, but that was pretty quick. And if we just maximize this, we get a summary of every variable that we have in our data set. And so here, ID, which is numeric, we can find the minimum, the first quartile, which is your 25th percentile, the median, which is your 50th percentile, obviously, the mean, the max. Obviously, none of those statistics mean anything for ID. It's a useless thing that's coming back. Case number, you can see here where it says class, it's character. So it's not going to give us anything like min or max because those don't exist for text strings. For date, I don't really know how to interpret this in terms of a date. I mean, min and max make sense, right? We have January 1st of 2009 all the way up to May 26th of 2014. Apparently, 50% of our data in our data set that we have it now took place before June 25th of 2011, if that's how you would interpret that. Our time ranges from midnight all the way up to 11 p.m. So here 23 means between the hours of 11 p.m. and midnight, where here 0 means between midnight and 1 a.m. And so 50% of our data falls before 2 p.m., 50% after 2 p.m. And we can just go through and look at all of that. Let's say we also want to see the range. That's just the min and the max. And so it prints it out, min on the left, max on the right. We could have also done the same thing. Maybe we just want the minimum. The minimum, obviously, in our data is 2009. That's the earliest date we set. Max is going to come back at 2014. And you can do that. So let's say that I do, let's say I make 1 million random numbers. They're just randomly distributed on a normal distribution. And I want to say, what's the max? And it finds it very quickly. I can find the min, I can find the mean, the standard deviation, the variance. I can find the square root if I want. That didn't work out quite as well as I wanted. I didn't think that went through. But all of your mathematical and statistical functions are available to you in a very easy way, and they're very fast and they're straightforward. Mean is called mean. Standard deviation is just SD. Variance is VAR. So they're all there for you, and you can even do things like, let's say let's make them smaller. So let's do random normal. Let's do 100 numbers. Y is a random normal of 100 numbers. And let's say you want to find the correlation of X and Y. It's just COR. The covariance of X and Y, if you're interested in that. So it has all of these statistical functions right there that you might need. Let's say that you also want to find the percent change in something. So for example, we still have our data set x2. So if we look at x.2, and we want to know how much did crime decrease, apparently, for arson it's a decrease here, from 2010 to 2011. We can do something where, how do I want to do this? Okay, so let's do it like this. Let's say that we want to know the total number of crimes that took place in 2009, regardless of what the crime was. So we can just do x.2 total 2009, and we can just say sum, and it'll come back and it'll tell us the exact total number of crimes in 2009. Let's say that we wanted to do that for all of our variables at the same time. So we can just do I believe there's 7. 1, 2, 3, 4, 5, 6, 7. Yep. So 2 to 7. And it'll come back and it'll tell us, and it'll categorize them. Let's say that we wanted to find the standard deviation for all of those. We can do that. We can even find the mean number of crimes. But that's by year. Let's say that we also wanted to do it by crime type. Let's say I want to know the average number of arsons that there were in the last 5 years, or even including this so far portion of 2014. So I can do I don't want to do all of them. Well, that did not go how I wanted. Let's figure this out. Alright, so that didn't come back quite how I wanted, but we can do this. And so here it names them a bit different. So if we look at the head, it wants to name them with the row names here because I excluded this crime column. Otherwise it wouldn't have calculated the sums correctly. But either way, we have these ways of taking our data and summarizing across or down, depending on which way we want to calculate those statistics. Sometimes we don't even want to sometimes we want to do more than just mins, means, max, things like that. We want to actually see our data and visualize it in table form. And one way to do that is with the actual table function. So you can do it with just one variable if you want. And so what this is it's the total number of crimes that took place in a given year. And we saw something like that when we created our x2 and then did the sum down the columns. And this is what we got back. We've also seen this table where we did the number of crime, or the crime by the year, and so we got the count for each crime in the year that it took place. So we've seen those. Something you might want to be able to say, well, how much crime is taking place within each of my districts, and so you can do that as well. One of the things about R, if you'll notice, is it tries to give you all the output that it can, but it does so within the realm of your boundaries here. So it won't go past this boundary. You'll never have to scroll left to right in your console window. So what it'll do is it'll just move the rest of them down here. So this is all the headings for your districts, starting at District 18 as it cut off here after 17. So it'll move that down and you can just keep looking. Something else you might want to do is get the proportion. So what proportion of my crime, or what proportion of my total crime does each crime make up? And so you can do that with a simple calculation. And these numbers are going to be really gross to look at just by their very nature. There's so many, and each one will only take up so much of it. But so for example, over here, motor vehicle theft is 4.67 times 10 to the negative 2. So you're looking at, probably about 5% of your crimes are motor vehicle theft. So again, we have these nice ways of looking at our descriptive statistics. We can summarize our data as a whole. We can look at the range, and we can look specifically at the min, specifically at the max. We can use our table function to either do crosstabs. You might know them as pivot tables within Excel. And then we can also take our table and then divide it by the sum of the table to get proportions for in terms of, so a better example might be, if we do, let's do that differently. So of the 1.8 million crimes that have taken place since 2009, 21% of them were in 2009, 20% in 2010, 19% in 2011, and you get the general idea. So we can just quickly summarize that information with just one quick command. So the other one, and I think this is the biggest one, is querying data. So we can query our data in any way that we deem possible. Again, our data is just a matrix, and so the way you're going to query in SQL, you do it with you kind of do it with plain English. So I might do something. Let me open this in a new command. I might do something like create table T1 as select distinct. And then I'll come down here and I might say ID, and then I'm going to do count I might do something like that in SQL to kind of query my data. In R, it's not as much plain English, but it's pretty close. What you do is you start with your data, and then you're going to use a square bracket. The square bracket, you can read that as saying where. So you're basically saying, give me my data, where, and then it depends on what you want to filter out. Do you want to filter out records? Because that comes first, and then you have a comma, and then you get the modifiers for your columns, and then you close the square brackets. So anything, any conditions that you put before the comma here, that will filter out records, and anything you put after the comma will filter out variables. So more often than not, we're probably just going to filter on records unless we want to build a new data set. And so we might do something like, well, I only want to look at 2014 data, so give me that. And so it does that. And so if I run a table on the year, I only get 2014. So we know that that came out right, and then if we look at it at the dimensions, I still have my 22 variables. The same thing that I had in my original data, the 22 variables. I didn't filter any of that out. I just got rid of a whole lot of records. I went down to 101,000 records just in 2014. And so even when you're telling R that you're subsetting your data, you still have to tell it that when you say year is equal to 2014, you still have to say, you know, that's the year variable that's in my data set. You can't skip that part. You also have to be careful of the double equals. You can use a single equal to set a variable. So when I type x, it's now a. Or you can use the double to ask if they're equivalent. So you have to be careful with that, but you use the double equal sign to ask for equivalency. We can also do it with strings. Give me all the data. I don't care what year. I just want all the data where the crime was a theft. So it does that, and if I say they're all just going to come back as theft. Another thing I might want to do is maybe just build out a reference table that I'm going to key between two different variables, or two different tables I mean. So I might want just this one reference table that is just going to be my UCR codes. And so I want all the records because I want all of the UCR codes in there, but I only want that one variable, just UCR. And so I can either type out the variable name, and so if I do that, and if we look at dim for UCR now, my apologies, it came back. It's not actually a data set anymore because it's going to be just a vector, which we can see here. So if we do head UCR, it is just a vector, but we can still use that to query or match on different things. So for example, I can now say, let's create just something temporary x, where it's in UCR 1 to 10. So it's if it matches the first 10 values of the UCR that we just created, then keep it. Otherwise, get rid of it. And so if we do that, and then look, we only have 582,000 records. So we were able to kind of bounce our entire data set off of that UCR vector and say, or the first 10 elements of that UCR vector, and say only keep what matches those first 10 records. Let's say we only want the UCR codes for where crime equals theft. So we can set row and column at the same time. So we say only give me the records if crime is equal to theft, and I only want the UCR column. And that is going to come back as a vector because there's only one dimension. Again, we're only keeping one column, so it comes back as a vector. And so if we look at that, we can see that the first 6 observations are different because this only applies to the UCRs assigned to a theft crime, where these are just all the UCRs that we found in our data. We can also do complex filtering in when we're subsetting our data. Maybe we want only the location description for thefts that took place in 2014. So we're going to say, give me all the rows where crime is equal to theft, and that's what this is here. You use the ampersand instead of writing out the word and the year is equal to 2014, and only give me the location description variable there. So if we do that, again, it's just going to give us this vector here because we only have one column, but we can look at that and we see that, you know, we've got our first six values. So we've got theft from a residence, a street, an apartment, you know, what have you. R is very good at querying data, and it's very fast. I don't think that it necessarily has an advantage over SQL, with the exception that I don't think Access could handle 5 million records. I tried to load data into Access, and again, I don't have a lot of experience with Access, but it didn't want to take anything over a certain number of records, and it was being very finicky about it and giving me a very hard time. So when I'm doing database stuff, I want to work in an environment where I can load millions upon billions of records if I have to, because I always want to have access to as much data as possible. And R does that. And even when you're dealing with extremely large data sets, it'll parse through and get you the information you need very quickly. So while I don't think that the querying language has an advantage over SQL, some of you might think it's a disadvantage because, like I said, you're not just typing in plain English like you kind of do with SQL. It's nice to just have everything under one roof. So the same place I loaded my data is the same place I manipulate my data. It's the same place I query my data. It's the same place I run my analyses. And so far, everything that maybe we've wanted to do with our data, I've done all right here in R. So something else that you might want to do is get the unique values. So for example, if we look at, I believe it was this one, here, you see that we have some replication. The UCR theft came back with 0820 3 times, actually virtually all of these times, except once, and you don't need all those duplicate values. Maybe you just want a list of the unique values that are in there. So if I say, give me the unique values in here, I now have a list of just the unique values. And so if I ask, you know, how long is UCR.theft, I see that it has 398,000 elements in the vector, and here I just got maybe, what is that, like 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 unique elements out of these 398,000. So you can reduce the size of that variable because everything you do in R will eat up your memory. And so the more stuff you have, the slower your computer will get. Although admittedly, you'll probably never notice. But it's good practice to try to keep your objects as small as possible. So you don't need all those duplicated values that you have in UCR theft. Maybe you just want to do it as unique and set an object equal to those 13 values instead. Because you're gonna, whenever you're bouncing your data off of that to keep a certain type of record, you're gonna get the same result. You're dealing with a much smaller object in that regard. You can also do, let's say I'm brand new to the department and I didn't know what type of crimes were being listed in our data set. I don't know what we're working with here. I can just do unique crime and I get all the different crimes that are listed. Couple reasons that that's nice is, one, it tells you how they're spelled out. So for example, criminal sexual assault, they type it as crim. They don't spell out the criminal. Another reason it's beneficial is I have things like this. I have the non-criminal where there's no spaces between the dash here, but over here I have non-criminal where there are spaces between the dash, and then over here where it says subject specified. So I can look at that and say, okay, well, maybe I want these three to just be the exact same. So I'm going to do something where I fix that. I see that I have interference with a public officer here, and I have, where did it go? Did I fix it? There should be an interfere with public officer in here somewhere, and I'm not seeing it. Might have been fixed, actually. So just a couple places where it's off by just a little bit, and I can see that because I'm pulling out the unique versus, and this is going to be overwhelming, if I just tried to type it all out, it's going to give me 10,000 of them, and I have to sit here and try to look through it like this, and that's a nightmare. Another thing you can do is with the UCR theft, So remember, we haven't changed anything there, and we have a whole lot of duplicates. I can say not duplicated, and it'll tell me if that's true or false. It'll give me it'll tell me if the record is a duplicate, which can be really good for data integrity. You can also use it to return, if you use it properly, it's the same as just using unique, but it's another technique that's in there. You can check to see if you have a duplicate record, and it checks across all variables. So let's say that your data set across all 22 variables, you think maybe you had some glitch in the record management system where it duplicated a bunch of records. You can use that non-duplicated function there to delete those out. It'll go through, it'll find the ones that are duplicated, it'll delete them out. But you have to be careful because sometimes, obviously, it might be the case where it should be duplicated. It's just a pure happenstance. Two people named John Smith lit fire to a factory. You just got to be careful with it. So some of the other things we can do is we can do our descriptive statistics while simultaneously querying our data without needing to create a new data set. So before, when I was querying, I said, store query the data for anything where the year is equal to 2014 and store it in a new data set. But let's say I don't want that new data set. I just want this to be a one-off, quick, answer this question. How many crimes did we have in 2009 related to the concealed carry license violation? Or here, we'll use in just total in a year, and so we can look at the range there, and we see that it only took place in 2014. Or, maybe I want to look at this for kidnapping. And if we look at that, we have kidnapping, the year will range from 2009 to 2014. That doesn't really tell us a lot, does it? But it does show that we can perform statistics on our data while subsetting it without needing to store that subset. We can do a one-off type of analysis and not worry about having to, create this whole new table based on the SQL statement we just ran, or or our filtering or querying. Another thing that we can do is here we're going to check the number of arrests by year for arson. So we run this, and this is only amongst arson crimes, and we can see whether or not there was an arrest by year. So here we see from 2010 to 2011 the number of arrests for arson went down, but it looks like the total count went down as well. I mean, you would find that by just summing the 458 and the 49, which you're looking at probably 507 here and 519 here. So 12 more arsons in 2010 than in 2011, but the arrests dropped by 15. So arson went down by 12, but arrests down by 15. You can start calculating statistics in that way. So a whole lot of good stuff going on there. Another thing you can do is find out, you can get a table of how many arsons took place on every street. So when I first got the data, one of the things I did was I parsed out the street name because I wanted to be able to do stuff based on that. So I want to find out how many arsons took place on every single street, but I don't want to view the output. I just want to store it in this variable x. And if we look at the head x, we see that on East 100th Street there were 4 arsons from 2009 to 2014. East 105th Street there were 2. And so if I was to just type out X, you get a whole slew of information here, and you don't really want to look through that manually, but maybe you want to know what street is the most prone to fires. And you can just ask that. You say, which X is the max X? South Union Avenue. 443 arsons over the last, I guess, 5.5 years, if we're going to include this portion of 2014. And so you might ask, well, how does that rate to the other streets? So what we're going to do is um, we're going to take the max x, this 443, and divide it by the mean of all x's. So how much bigger is it over the average? And so if we do that, we see that it's about 5.6 times higher than the average. So that's a lot of arson. And so again, all of this is just done right here, all under run roof. And as long as you know how to work the querying language, you can subset your data for these one-off type exercises, get the numbers you need. You can store the numbers if you want, or you can just get them to be output here. Maybe you've got an email from the chief asking, what's the percent change in arson from 2009 to 2010. You don't need to store that in anything. You just want to quick run the numbers. You've already got your data in R. You're just going to go in and you're going to do it really fast. Another thing you might want to do is plot data. So for example, let's just look at a quick histogram of crimes by year. And so the beautiful thing about R is I can just say hist, and it gives me this really atrocious graph. So if we click zoom, this is very boring. We have white bars. This histogram, sorry about that. This histogram of DAT $year, we would never want that on a graph. DAT $year down here. These numbers are sideways, and this just says frequency. So the beautiful thing about R, and this is probably its biggest feature, is your control over plots. If you were to go online and Google fancy R graphs or complicated R graphs, it's absolutely amazing the stuff that's out there, like 3D contours. You can find, I think it's possible to create GIFs in R, so like these, you could do a time series GIF of hotspots as they evolve over time. That's a little bit outside of what I know, but I'd love to learn that, but it's possible. R's graphics for plots are very, very sophisticated. And so here I'm going to do things. I'm going to enhance on what I typed here. So I just typed hist.year. I'm going to type that now, but I'm going to change some things. I'm going to change the X label, the Y label, the main label. I can change the size of the font on my tick marks. So here, like the 2009 and 10 and these values here. I can change the size of the font for the labels, and I can change the color of the bars. So maybe a gray might be something to look at, or maybe we want like a light blue. And that looks like something more worthwhile presenting to somebody. Now this is obviously still not the best graph ever. For example, year is really, really tiny, and same over here. And 4 times 10 to the 5th power is not a value you really want to see on your scales here. You'd probably want to divide the counts in some way so that they were in thousands. And I even tried saying that they were in thousands here because they were supposed to be. But you also have a lot of spacing between your bars here, which it's not very aesthetically pleasing. But you do get a general sense that crime has been going down over the past few years, so that's nice. And we changed our title up here. It's more meaningful. But that gives you a glimpse of some of the base graphics you can do in R. It does get a little bit more complex. So before we get into the really complex, let's do, let's see. Let's do all of this. Let's say that you want to plot your Part 1 crimes by violent and property by year as a line graph. So we're going to do some data manipulation to get our data ready to do that, part of which is aggregating it and creating a few new variables. And then once we have all that, we now have this nice little graph that shows our Part 1 crimes by year. We have two different axes you can see. So our property crimes in the thousands are over here on our second y-axis, and we have violent crimes in the thousands over here on our primary y-axis. Everything is labeled. You can see that the axis labels are readable. These are not in weird scaled scientific notation, and we have a nice meaningful title at the top that could maybe be a little bit bigger. And we would also want a legend to be attached, but we have control over that. We can add that if we want. For the record, if you're curious, R is violent and blue is property. But we can add that legend in. We can tell it where we want it to be, whether it's the top right, top left, bottom, bottom right. We have total control over R. So let's do something a little bit more complicated. This is something I saw online, and so I tried to replicate it. I'm not that great with ggplot. ggplot is a very sophisticated graphical package in R. It stands for the grammar of graphics. That's what the GG stands for. And there is a whole slew of stuff you can do, and I have not even touched the tip of the iceberg. But I did some research online this morning and figured out how to do this based on a product I've seen done for crime analysis departments. And I would want to tweak it some more to make it worthwhile using, but I think it hints at what is potentially possible in R. I apologize for the delay in this aggregate function. I should look into a new package that does it faster. But as for now, this is what we have. What I'm doing right now is I'm aggregating my crime, the total number of crimes by day of the week and time, and that did not work at all how I wanted. Let's see if we can fix that. Sorry about that. That is what happens when you modify your syntax mid-afternoon and don't actually pay attention. So here I tried to get at that map that I've seen used where you have the days of the week on one axis and the time on the bottom to kind of generate this heat map that shows where your troubled times are for crime. So we see here that on Friday between maybe like 1800 and 2300 is a real trouble area. During the week around noon seems to be a bit of a trouble area in Chicago. And then over here, early morning, very early morning during the week, obviously not the case. We have our scale over here going from green to red. Again, this doesn't look as neat as some of the other ones I've seen, and I believe there are ways to kind of melt the distinct lines that you have here, like clearly defining these rectangles. I think you can melt those a little bit so it's a bit more smooth, but this was my first attempt, and I really just wanted to show that stuff like this can be done in R. So in addition to just doing analyses on data, R can also do really great things in terms of link analysis, text analysis, and using social networks. Now, this is something that I'm just starting to get into. I tried to get Facebook to work earlier so that I could use this package called iGraph, which would potentially be able to replace IBM's i2 Analyst Notebook, because I was talking to Glenn. He said that's extremely expensive, and you're really just using it for link analysis, and I think that you can do that in R. Unfortunately, the Facebook package, Pablo Barbera, who put it together, seems to be having a bit of a difficulty. Everything's coming back telling me it's deprecated and can't be used, so that didn't work. The Twitter, though, Twitter does work, and let's see. I'm going to clean up my data because I don't need any of that stuff anymore. So we're starting fresh. I'm going to load a few things. I did this on a different pack because I have some keys I need to keep hidden. So getting rid of that. We're going to get me as a user, and then now I don't use Twitter a lot, so that's why I'm not going to go too in depth with this. This is more of a theoretical or thought experiment. So I can't actually build the graph because, let's see, if we get my friends, I will show you why. I have stuff like CNN Breaking News or The Economist or The Economist Business Financial, Wall Street Journal, you know, all of these really boring things because I just use it for quick news blurbs. I do follow James Roday and Dule Hill. If you've never watched Psych, I would highly recommend it. It's fantastic writing. Fun little series. But so most of my friends are not actually friends. But for example, let's say that I got the user Nate Silver. He is the person who predicted every single election for 2009, I believe. He's a predictive analytics guru. He wrote the book The Signal and the Noise. Very cool guy. And if we get his friends, this is going to take a bit longer. He has much more than I do. I'll go ahead and I'll open up the structure and show you the type of stuff we can do, and then also show you some of the other things that are possible. So if we look at the structure of friends, we can see all the information for all of his friends. And the reason this is nice is, let's say you have a suspect or even just a person in your city, right? And this goes to that 80-20 rule, 20 or 80% of the crimes done by 20% of your perpetrators. So you get their names and you go to Twitter and you say, you know what? We're going to use this and we're just going to build a network analysis or an adjacency matrix. We're going to know who all of your friends are. We're going to have the information. We're going to keep track of your tweets. We can do that very easily with just a run of a program every morning. We're going to see what you're talking about. For higher up, if maybe you're doing money laundering or organized crime, you can use Twitter to see what people are talking about, or even just gang-related narcotics type stuff. It's of course, I'm not in the field, so it's hard for me to completely visualize what this is capable of, but I have a lot of thoughts in terms of what it can be used for, and I think it is being used for a lot of things already. But my point is that even in your department now, you can do this. You can start building this database of repeat offenders, getting who they talk to. You can find out who they're talking to the most. Who are they retweeting? Who's retweeting them? You can do text analytics in terms of what their tweets are, and maybe start picking up on things. Maybe they're using code and talking online to set up drug buys, or maybe you get that idiot who decides he wants to flaunt on Twitter that he just stole something. You never know what you're going to find, but it's possible. And as this Facebook package gets tweaked and fixed, it'll become even more possible, because you then have access to all of their friends, and it's much easier to build an association matrix and map out the network. And you can add in profile pictures, and you can weight the edges by how often they communicate with that person or how closely they're connected. There's just a wealth of information that's possible. And again, you don't need that really expensive package from IBM. You just need R and a little bit of free time to read through the help pages. So if we're looking through, we have this person here. Their Twitter ID is this. They are a user. Here we have a description. This is their little headline that they put up. They're a Stathead sports writer working for 538. That's the blog that Nate Silver started. We have the number of statuses they've posted, how many followers they have, how many things they've favorited. The friends count is how many people they're following. So followers is how many people are following them. This is how many people they're following. We can get their URL, their actual name, and we also have their screen name and where they live. So you can use that to loop through each of those people and get all of their friends and start building this really elaborate network analysis if you want. I tried it earlier. It didn't work out the way I wanted. I need to work through a few more kinks, but this is something possible. something else you can do is, I believe, how does this work? Pardon me while I figure this out. So we can just do, I think it's search Twitter. So if we look at the arguments for search Twitter to figure out what we need, we just need the search string and however many we want. Okay, so let's say you want to search for trends or certain hashtags or whatever else on there. One of the ones that's near me is called Crime in the D. There's an actual Twitter page called Crime in the D, and so people will use this hashtag to repeat about, or to tweet about crimes that they've seen or something they heard on the news or something they saw. Let's see, unused arguments. Oh, that's because I just said search. It helps if I actually use the full function. And so I'm gonna ask it to return 100, and now I can get all of the tweets that have the hashtag crime in the D. And I don't need to be on Twitter, I'm just doing this all in R. And what I can do is I can then save this and I can loop through and I can look for keywords and try to figure out what people are mentioning the most right now in terms of crime. Perhaps I don't even want, because if you notice these are all just retweets of the exact same thing. 12 homicides and 100 shootings during the past 10 days. Yeah, welcome to Detroit. Perhaps I want to do something like get the tweets of just one user, and so let's do that. So we're going to get the tweets of just a specific user. Maybe you have a suspect in the area and you're just checking up. You want to maybe see if you can find some information on them by going to their Twitter. You can say user timeline, user equals, and let's just do crime in the D again. And so when you do that, it gives you their last 18 tweets that they've sent out. And these are just news clippings for stuff that's been going on here in Michigan. Something about Farmington Hills, here's something at MSU, removal of goats from Detroit, again, welcome to Detroit. But you can see that just going on and finding, just getting the user timeline from somebody. This is a buddy of mine, he lives out in New York. Let's see what he's talking about. These are all the different things that he's been tweeting about, the last 19 tweets. I believe the default is 20, but it looks like it's coming back with 19. I'm not sure why it's doing that. But you can see he was upset about Delta because he had some flight delays. He's been running lately, you know, a little shout out to his mother. So you can see all these different things that people are doing on their Twitter without going to Twitter, manually finding their page. If you know their username, you can just do all of this right in R, and you can start analyzing their tweets. You can build a network analysis. You can do all of this different stuff. So hopefully that gives you a nice glimpse into what R is capable of in terms of being this full spectrum of tools available to you to cut down on how much you're transferring data from one program to the other, or how much money you're paying for things. Hopefully it sparks some interest in terms of, you know, what else can it do, and, you know, I'd love to hear your feedback. If this is something you think you'd like to know more about, please, you know, get a hold of me. You can send any feedback or questions to my email here. But, you know, I just wanted to put together a quick little tutorial to highlight some of the things that R can do, and, you know, hopefully present a way to start streamlining processes, or even start alleviating some of the questions of how do we validate the costs in our department. You know, maybe this helps save your department some money with seat licenses over time. So who knows? If you have any questions, you know, let me know. But hopefully you enjoyed. Thanks.